In module number 1, we'll discuss computation accuracy in DSP implementation. Computation accuracy in DSP implementation. Here we'll discuss the number formats. Here we'll discuss some number representation. Okay, here in a DSP, signals are represented as discrete set of numbers from the input stage along through intermediate processing stages to the output. Okay, here the signals are represented as a discrete set of numbers, from the input stage to output stage. In between, you can process input stage along through intermediate processing stages to the output. Okay, even DSP structures such as filters require number to specify coefficients for a operation. Coefficients for a operation. Okay, here there are two types of the formats, number format. One is fixed point format. One is fixed point format. Second one is floating point format. There are two types of the number formats. One is fixed point format and floating point. Okay, first here we will discuss about the fixed point format. Here the fixed point format can be classified as integer format, fixed point integer, and fixed point fractional format. Okay, fixed point format is a simplest scheme. Number is represented as an integer or fraction using a fixed number of bits. Using a fixed number of bits. It's a simplest scheme, and the numbers are represented as either integer or fraction. Okay, then here, what is the number format for the numbers? What is the fixed point format here? An n-bit fixed point signed integer. Its range is from minus 2 raised to n minus 1. Okay, x is greater than or equal to minus 2 raised to n minus 1, less than or equal to 2 raised to n minus 1 minus 1. 2 raised to n minus 1 minus of 1. This is the range. This is the range. Okay, x is equal to minus s into, this is the fixed point signed integer format. This is for fixed point signed integer format. X is equal to minus s into 2 raised to n minus 1 plus b of n minus 2, 2 raised to n minus 2 plus b of n minus 3, 2 raised to n minus 3 plus and so on up b1 into 2 raised to 1 plus b0 2 raised to 0. Here b0, b1, b of n minus 3, b of n minus 2, these are the binary numbers. These are binary numbers. This one, this one, this one, and this one. These are the binary numbers. And what about s? What is s here? Anybody? What is s? What is s? What is s here? Here, s represents, okay, s represents the sign of the number. If s equal to 0, it's positive number, and s equal to 1, it's a negative number. Okay, this is the number format. Which number format? Fixed point signed integer number format. Its range is x is greater than or equal to minus 2 raised to n minus 1, less than or equal to 2 raised to n minus 1, minus of 1. Okay, this is the number format. Just remember, where s represents the sign of the numbers. If s equal to 0 is positive number, s equal to 1, it's a negative number. Okay, just remember here, right side. Fixed point integer format. What is the most negative value that can be represented? This is the most negative number, right? The most negative number, which is the most positive number. Okay, here if the what is the most negative number, negative value that can be represented? If when we consider that it's negative, how we can represent it's a negative value when the s bit is 1. If s bit is 1, then we say that it's a negative. That's why here only s bit equal to 1 made here s equal to 1. The remaining bits I made it as 0, 0, 0, 0. What left here? Minus 2 raised to n minus 1. Okay, here it's represented 1, 0, 0, 0, and so on. Minus 2 raised to n minus 1. This is the most negative number, negative value that can be represented. Okay, determine the most negative number. Write down the number format x is equal to this one. Okay, then here in s equal to 1. Why s equal to 1? Because when s equal to 1, that means sign bit. It's a sign bit. That's why okay, s equal to 1 into 2 raised to n minus 1. The remaining bits are binary values are 0. Then minus 2 raised to n minus 1. Here, for how we can determine the most positive value? That can be represented by the fixed point integer. That is, here when we say that it's positive when the s bit is 0. That's why I made here s equal to 0 and remaining bits are 1. Remaining bits are 1. Okay, these bits are 0. Okay, then here that represent the most positive value is 2 raised to n minus 1 minus of 1. After simplifying this, we will get here 2 raised to n minus 1 minus 1. Okay, this can be represented as 0, 1, 1, 1, and so on. Okay, just remember this number format, and this is the range. This is the range. This is most positive negative value. This is the most positive value. In problems, they ask for determine the range. Okay, determine the range for fixed point integer numbers. Then write down what is the n value. They given n value, substitute it. Then you will get the range of x. The most negative value and most positive value here you will get. Okay, see here. They given one example is they given here n equal to 3. N equal to 3 means what is the integer range here? X is the most negative number is minus 2 raised to n minus 1. Most positive number is 2 raised to n minus 1 of minus 1. Substitute here minus 2 raised to 3 minus 1 less than equal to x less than equal to 2 raised to 3 minus 1 minus 1. Here what we get here? Minus 4 and 3. Then here we write minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. Okay, then how do you represent the number x equal to minus 2? If it is minus negative value, how we can represent? See here, just consider here minus 2, right? If it is minus 2 means it's negative value, right? What is the s value here? What is the s value here? What is the s value? 1. Okay, 1 into, okay, right here, leave it. Then 2. 2, how will write here? 1, 0, right? 1, 0, right? 1 binary number and 0. Okay, this one is 2 raised to 0. This one is 2 raised to 1. This one is 2 raised to 2. See here, minus sign. You can write minus sign. X equal to minus 1, 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0. The numbers are 1, 1, 0. This represents the minus. Okay, please this number format is very important, and this number range. Okay, please go through the number range here. This one is very important. Okay, they will give numbers like this. When n equal to 3, what is the number fixed point integer range? Okay, next one is fixed point fractional format. Fixed point fractional format. Here we know that this is the range. This is the range of the fraction number. Fixed point signed fraction. The most negative value is -1. Most positive value is minus 1 minus 2 raised to minus of n minus 1. This is the most positive value. This is the most positive number. Okay. Then here, what is the number format? How we can represent the fixed point fraction number? Here, minus s 2 raised to 0 minus b of minus 1 2 raised to minus 1 b of minus 2 2 raised to minus 2 plus and so on up to here b of minus of n minus 2 2 raised to minus n minus 2 plus b of minus of n minus 1 into 2 raised to minus of n minus 1. Okay, so here please go through this. This is very important, this number format. Okay, sorry. This one is very important. Please go through this whole. Okay, again same here. When s equal to 0, it's positive number. When s equal to 1, it's negative number. S equal to 0 for positive, s equal to 1 for negative. Now here we can represent what is the most negative value and what is the most positive value. Consider the same format here. For most negative value means s equal to 1. The remaining bit values are make 0. See here. See the number format here. Okay. Here we substituted minus 1 into 2 raised to 0. Minus 1 means it's a sign bit. It's a sign bit. Then we got like this. In all the b of minus 1, b of minus 2, b of minus 3 and so on, the bits are as 0 only. Then the most positive value is minus 1. Just remember, this is very important. Then what is the most positive value that can be represented? Write down the number format here. In the place of s, substitute 0. The remaining bits are 1. Most positive values. Okay, then we'll get, fraction range is, fraction bit number range is 1 minus 2 raised to minus of n minus 1. Okay, see here. If n equal to 3, n equal to 3, okay, what is the n equal to 3, what is the range? What is the most negative value and what is the most positive value in the fixed point fractional number? Here n equal to 3, x equal to, x equal to here x equal to, x greater than equal to minus 1 less than equal to 1 minus of 2 raised to minus of n minus 1. Here you can substitute n value. Yeah, that is 3 here. 3 minus 1, it becomes minus 2. Then minus 1 as it is. X minus 1 less than equal to x less than equal to 1 minus of 2 raised to minus 2. That is 3 divided by 4. Then you can write the increment order. Okay, x belongs to minus 1, minus 3 divided by 4, minus 1 divided by 2, minus 1 divided by 4, 0, 1 divided by 4, 1 divided by 2, 3 divided by 4. This is the most positive value. This is the most negative value. When n equal to 3. When n equal to 3, this is the most positive value is minus 1, most negative value is 3 divided by 4. Okay, next one. How do you represent the number x equal to 1 divided by? How you represent x equal to 1 divided by 4? How we can represent x equal to 1 divided by 4? Anybody? See, just refer the number format. This one is the number format, right? Okay. See here. 1 divided by 4 is positive value, right? If it is positive value means s equal to 0. Okay. S equal to 0. Then here n value is equal to 1 divided by 4. What is 2 raised to minus 1 here? Is 1 divided by 2. That means 0.5. But 1 divided by 4 is 0.25, right? 1 divided by 0.25 is n value is 0.25. That means n equal to 1 divided by 4. See here, what is the value of this one? 2 raised to minus 2. What is the value of this one? 2 raised to minus 2. It's 1 divided by 4. Okay, then here I represent like this. See, x equal to minus s raised to s into 2 raised to 0 plus b of minus 1 2 raised to minus 1 plus b of minus 2 2 raised to minus 2. Okay, x equal to 1 divided by 4, right? See, I will write this one in the number format. S equal to is positive number. 1 divided by 4 is positive number. Then I will write it 0. Okay. Then b of minus 1 it's 0. Okay. I'll make this bit as 1 because here x is 1 divided by 4. That's why 2 raised to minus 2 is 1 divided by 4, right? Then 1 divided by 4 is equal to 0 into 0 0 1 0 0 1. Okay. See here, if I will change the value x value, I will change the x value. What I will do here, I'll change it to 1 divided by 4. Sorry, 1 divided by 2. How will write 1 divided by 2? It's positive number? Yes, it's positive number. That means here I will substitute 0. Then 2 raised to minus 1. 1 divided by 2, right? If you wanted to get 1 divided by 2, I will make b of minus 1 as 1. This one is 1. Okay, 1 into 2 raised to minus 1 plus. Here, b of minus 2, I will make it, the remaining values are 0. Remaining values are 0. That's why here 1 divided by 2 is equal to 0, 1, okay, only 0, 1. No need to write this one also, this term also. 1 divided by 2 is equal to 0, 1. These are the coefficients 0 and 1. Like that you can represent the numbers, okay, in space, fixed point, fractional form. Okay, just remember that. Next one, Next here, fixed point format. Fixed point format to represent the signed integer. Fixed point format to represent signed integer. Here, this is the signed integer format here. Fixed point signed integer format. S, B of n minus 2, B2, B1, B0, these are the binary numbers. S is the signed bit. Okay, the binary point will come here at the end, where fixed point format to represent signed integer. In fixed point format to represent signed fractions. Here, in fixed point format to represent integers, signed integer, the implied binary point will come after all the binary values. Okay, for fixed point format to represent signed fractions, in this the implied binary point will come after the signed bit here. Okay, this is about the fixed point format. Okay, here we discuss both signed integer and signed signed integer and signed fractional. In signed integer, just remember the number range and number format. Okay, and go through the examples. Similarly, for fractional format, just remember the fractional format. Okay, where this? Yeah, okay. This fractional format number. This is the range, and how we can represent, find out the most negative value and most positive value. Okay, in the next class we'll discuss floating point format. Okay, thank you.